about internet security, weaknesses and targets. Today we want to speak about browser and the weaknesses of the World Wide Web. This is one of two lectures because there is a lot to discuss. We have already discussed that in the systems that are interconnected by the internet, there are many, many points to attack such systems, and there are many security risks that coming from the communication, from the internet protocols, risks that come that are provided by the operating system, by the various operating systems, risks that come from some mistakes in programs and others. We have discussed all this, and now we are approaching the end of this chapter, and we have to discuss weaknesses of the World Wide Web. The World Wide Web, www, the web, is a very user-friendly and intuitive interface in order to access resources in the internet. Everyone knows this, even people that have no idea about how IT systems are working, what are the technique behind. They can use the web and they can use resources in the web. And insofar, the killer application of the internet, the applications that made the internet so a famous and basic infrastructure for modern society was the web. It has become popular about 93, 94, and it was invented earlier, but it became popular in the moment when Netscape provided a browser with a graphical user interface. And by means of the graphical user interface, internet and World Wide Web and services of the internet could be used also by people that have no understanding of computer science because it works easily by point and click. Nowadays, the web technologies are the central activities of central importance for internets, and also when internet technology is used inside a company, inside a corporation as an intranet. The World Wide Web, you know this, has three basic columns. There is the HTML. This is the language, the hypertext markup language, which is used to describe the resources of the World Wide Web. Then we have, as a second column, the HTTP, the hypertext transfer protocol, the protocol that's used for transferring information, web resources over the internet, making them accessible. And as a third main thing we have in the World Wide Web, the URL, the Uniform Resource Locator. This is necessary and it's used and provides a possibility to exactly identify resources in the World Wide Web. The basic architecture of the World Wide Web is based on the client-server paradigm. Also, this is very well known to you. We have on client side the browser. So the browser is the client in the World Wide Web. You know that there are several popular browsers like Firefox, like Netscape Navigator, like Internet Explorer, like Google Chrome and others, which make the web resources easily usable. In most cases, these web clients integrate also clients from other internet services, like email clients or others. So in this way, the browser provides an integrated tool to access resources in the internet. But like all these nice things, the weaknesses in the design and in the implementation of the World Wide Web and particularly of the application of the World Wide Web also provide critical security targets. And in this lecture, we want to speak about this. Such critical security targets are particularly the communication that's based on the HTTP protocol, and the HTTP protocol performs all the interaction in plain text. Another risk comes from the point that there are only very rudimentary mechanisms for access control in the web. And so it's difficult to distinguish between authorized and unauthorized user. Then there are various new technologies. Technologies like XML, RSS, SOAP, Ajax, JavaScript, XML, Adobe Flash, PDF, and many other things, which are widely used, widely applied, particularly in the Web 2.0 applications, which are the basis of the social web, the so-called social web, social networking sites, blogs, wikis, video sharing, and all these applications provide different security risks due to some failure in the design, due to some implementation mistakes. What we want to do in this and in the next lecture is to discuss this in more detail. If one looks to the most important security risk, there is in the open web application security projects, there is a listing of the top 10 of this web application security risks. The last one of this list comes from 2010, and here it lists the following security risks. The first group comes from design and programming errors on the application layer. So most important and most dangerous and top one in this application security list are injections. Then the next are cross-site scripting, broken authentication and session management, insecure directory object references, cross-site request forgery, insecure cryptographic storage. These are the 7 most important application security risks in the web. Then the next group comes from administration and from configuration errors, also in the application layer. So we have security misconfigurations, we have failure to restrict URL resources, and we have invalid redirects and forwards. And then we have errors on the transport layer, and here it's listed, it's top 9 in the top 10 list. We have insufficient transport layer protection. So these are the main important security risks in a web application using the website. And my guess is, even if we see a new list, a new ranking, there will be no much change in it. So what we want to do in the lecture now is to look into more detail to understand the basic and why this, what are the problems that we get risk from this. If we look to risk in World Wide Web, then we can distinguish mainly 2 categories. First categories comprise those risks that comes from browsers by viewing web pages, by using web applications or web services on the client side. Risks on the client side, this is the one category. And the second category is risk by providing information and services in the web, and these are risks that occur on the server side. And following this categorization in this first lecture about weaknesses of the World Wide Web, we want to concentrate on this risk from the category 1, on the risk of this client side. The major danger when using web browsers is the unexpected loading of malicious content from web pages. from web pages such as malicious programs, for example, Java, Java applets, JavaScript, ActiveX, from loading manipulated files, for example, PDF, JPEG, Flash, or others, by insufficient protected sensitive data, for example, the activity logs or the cache of a browser or the history files or bookmark files. Here, attackers can get a lot of information about the user of a browser, and later on they can misuse, for example, in a password attack or others. So let's start with first risk in the area of spying out personal data, misusing a web browser, access to web browser, access to the client in the World Wide Web. To see what is the problem here, we have to remind that most activities, when a browser is used, are automatically recorded in relevant activity logs. So we have a history file, we have a bookmarks file, we have cache, we have cookies. All these things are introduced and invented to support the user, to make it more convenient to use the web and the resources. But as we have seen in many other places in the lecture, is things that are provided to make the life more easy, more convenient for user, have also a backside that when they are misused, when they are come into the hand of bad guys, then we have some disadvantage of it. So the goal here is from spying out such data, such information that are provided by the browser. The goal is to simplify action replay. For example, to access again an already visited website, to retrieve meaningful information, to execute commands, to save credentials, to get access that former was get by an authorized person, now to try to get access by an unauthorized person. This is very generally the goal of these attacks, and the security risks here are that if an attacker gets access to these activity logs, then he or she can spy out or apply data mining techniques for getting personal information about the user. Personal information, personal preferences, hobbies, interests, purchase intentions, plans for job cancellation and others. And such information can give hints, for example, for password guessing attacks or for other things to spy out the user of the web. Let's start with some of the activity logs. Let's start with have a look to the history file. So the history file saves all the addresses, the web addresses, these are the URLs of the visited web pages by a user during a certain period of time. So by default in the Internet Explorer it's 20 days, by Firefox it's 9 days. And the idea behind is to make it easy for the user to access a website he has already accessed and he found some interesting and he wants to revisit. This is this is how such a history file looks like. So they are exactly the URLs of all the pages that are visited by the user. What is the security risk around this history files? Security risk is that if anyone has access to the history file of a user, then he or she gets detailed information about all websites the user has visited, and the websites a user which a user has visited, give insight, give a lot of information about the interest, about activities, about purchase activities or others of the user. So one can get access to very personal information. Similar is true with the feature, with the activity log of the bookmark file. Bookmark file, every browser provides such a tool, such a mean, the bookmark file, which allows the user to define a personal content or preference table of the World Wide Web. So the pages he or she wants to frequently visit. The security risk here is that bookmark file contains important personal information about the user, and this can be misused, for example, to perform a social engineering attack, because one can know I spoke with your friend and then tells the real name, or I'm also a member of this club or whatever. And in this way, the user thinks, oh, it's a friendly person, and then he's willing to tell more than he would be tell to an unknown person. One can use this for a password attack. You remember, very often chosen password are the main hero in cinema, or the name of the band most likely used, or family information or others. So all this one can get, all this information one can retrieve from such an activity log like the bookmark file. Another activity log is a cache. Remember, the cache contains complete web pages which are visited during the last hours or days. How many of these pages are stored, it depends from the cache size, and the more and more powerful devices are, the larger typically is such a cache size. The cache offers, the idea of the cache is to prevent large communication efforts and time to access a web page when this web page was already visited in the last time. So cache offers performance advantages, cache offers cost advantages. If an already visited web page is requested again, then it's only to check whether the cached website is fresh, and if it is fresh, then it's no more loaded. It's shown from this internal memory. The security risk here is that from a cache content, many data can be reconstructed that are of interest for an attacker. For example, username, credit card numbers, access data, and so on and so on. Here is the abstract of such a web browser cache. So you have all the details that are presented on the website are cached and can be accessed. So let's have a look at such a cache attack scenario. The goal here is to get access to a protected website. To a protected website that formerly was visited, was accessed by the user, which was authorized to access this website. The idea is the following. The attacker accesses, so what's needed is that he knows that he has access to the cache file of to the browser cache of the user. So the procedure is that the attacker visits the corresponding website, and then, of course, it will cached in his own cache, and then he compare his own cache with a cache of this web, with a cache with what was cached on the user side, and then he has only to find out what is the difference. And the difference are, for example, the correct authorization that was given by the user. So he has to compare the own cache of this website with the captured cache of the victim system, and then he or she has only to replace the appropriate strings. Then the attacker can also access the website which needs an authorization. And the attacker can access this because without understanding, he used the authorization of the victim, by means of the cached content of this login information. Of course, the success of such an attack depends on the way how the authentication technique is implemented on the protected website. There are possibilities to make such kind of attacks impossible, but you know there are many applications in the World Wide Web, and many of the services are not perfectly secured. So there is a chance that in this way an unauthorized user can access a protected website. Let's have a look to cookie files and security risk around security files. You remember the HTTP protocol is a stateless protocol. There is no possibility to remember something. So cookies were invented originally by Netscape to provide the server a possibility to remember a user. So in a cookie file serves to store some characteristic information of the already visited web servers. By means of this cookie, the web server later can identify the user, and he can remember that the user was interested, for example, in a shopping website, was interested in a men's suit, and from this producer, from this size, and he has already bought before that and that, and this information helps the provider to offer to the customer personalized things. So cookies are the mean to remember the status of former interaction. The format of such a cookie file looks as follows. There's a name, there is an expire date, there is a path, a domain name, and other thing. So if we have a closer look, specifications of these cookie files, you can find by the W3C standard on HTTP state management mechanisms. Meanwhile, originally the cookies were invented by Netscape, but it was a very functionally tool. So meanwhile, it's standardized so that everyone can use it. The example of such a cookie file looks as follows. Here you have the server name, and then the details that help the server to remember the interaction with the client. So what are the security risks around such cookies and that around the cookie mechanism? In order to fulfill their task, of course, the cookie files are usually be readable and writable from each web server, from each external place, because the server, the web server, the external web server has to write the cookie, has to place the cookie on the client side, and then when next time the client visited the server, then this cookie is transported. Therefore, gathering and misuse of collected data from cookie files is possible. For example, when a third party collects consumer dates through such technologies like cookies, which are not really apparent to consumers. A consumer does not really understand what kind of information is stored in the cookie. Then this creates privacy risks and resulting from consumers' inability to make informed decisions about their data, because then if people know exactly what are the preferences of the person, they only show things that fit to this problem. So the cookie mechanism itself is does not provide any kind of unsecurity, but the cookie mechanism provides a possibility to collect data about private interests and private activities. Let's come to another area which plays an important role in the World Wide Web, in the interaction between the client and the server. Let's speak about Java and some of the security risks in the environment of Java. Java, you know, is a programming language which is almost 20 years old. It was invented in 1995. It was introduced by Sun Microsystems. Sun Microsystems, you know now, belongs to Oracle. Originally, this Java was designed for application in the area of interactive television and to control household devices. So it was not designed originally for the World Wide Web. It was designed by the electronic consumer industry to provide means for the user to for interactive use of TV and for controlling household devices. For that reason, it was very important that Java was designed platform independent, because with its household devices you have very different producer and it should work with everyone. So Java is platform independent, and for that reason it was easy applicable for all the applications in the internet. And this applicability is reached by means of so-called Java virtual machines, JVMs. And for each platform, such a Java virtual machine provides the possibility that Java programs can be run on this platform. This Java virtual machine interpreted the Java bytecode and performs it on the platform, and it could be each platform. So Java is platform, but of course the Java virtual machine, this have to be designed for each platform to provide the possibility that Java programs can be run. Today, the Java programs are often used for internet and web application. So the idea and the usage and the attractiveness of Java comes from the fact that in the beginning, the web was a very static thing. You have the HTML pages and they show something and then to move. But all the kind of interaction, all the kind of dynamic, intelligent applications and usage of the internet and World Wide Web can be implemented by means of Java programs. So Java is very attractive. The so-called Java applets are Java programs which are loaded from a web server onto over the internet to the client, and which are executed on the local client. These Java applets are executed inside within a browser. So this is the idea of such Java applet. You know, typically some dynamic content is produced by ZGA over this common gateway interface on the server side, and by means of using Java the dynamic content can be produced on the client side, which is often much faster than doing this on the server side. In order to be able to execute such a Java applet, the client needs a Java virtual machine. This is a Java interpreter. And the Java interpreter gets, and this is what is transmitted over the internet, the Java bytecode. So if Java is used, the Java applet is used, then the client loads over the internet from the server the Java bytecode, and then this Java bytecode is interpreted on the client side by means of the Java virtual machine that is part of the plugin of the web browser. And this is the advantage of this mechanism, since these Java applets are completely executed on the local website, completely executed on the local client, many of them are much faster than CGI scripts which run on the web server, and only the results are displayed, are transported to the client and displayed by the browser. So this is the principle of Java. There is a web server, and the web server offers a Java program, and the clients that interact with the web server, they receive the bytecode, the Java program, in form of bytecode, and then the bytecode is executed on the client side inside the browser. The Java applets can be very easily integrated into web pages. This can be done by the HTML tag applet. Here is an example. An applet, code base, code with height, then parameter. And there is a meaning of the thing. So the code base here in the applet option code base, there is specified the URL of the Java program file. So by activating this URL, the Java applet is transferred to the client, Java applet in form of the bytecode. This was the code base. The code specifies the file names of the Java applets, and the executable Java applets have the file extension class. Here, for example, you can see this, and the parameters. They define the parameters. They define the parameters of the Java program. So this is the mechanism of a Java applet. The source, also you know this, for developing such Java programs, documentation, and all the bug lists you can find here in this Oracle page. What about security issues around Java? The conception of Java provides various security functions. So, for example, it's not allowed to use pointer. It's not allowed to use global variables. It's not allowed to use global functions. It's not allowed to preprocessor commands. So all these are security features. So when Java was designed, of course, it was an important point, if you have such a platform-independent technology, that this does not provide risks and dangers for the user of such Java applets. There is a conception of a so-called Java sandbox. And the idea is that the applet run in such a sandbox, and this sandbox prevents that the applet can access to resources, can do some dangerous operations outside this pre-located area and the resources that are provided for performing such an applet. There is an exception because sometimes it's important that an applet get access to some resources on the client side, to some files or to other things. And this is only possible if one works with signed and so-called signed and trusted applets. Here they can get privileged rights. So you are involved, you know these techniques. I do not want to go into more detail. I want to explain some of the security risks around Java. Although there are, we have clearly to say, although there are a lot of security mechanisms and a lot of prevention and a lot of good conceptual work with Java, there are some remaining security risks. For example, the use of certain Java classes in a Java applet can relay the control of the web browser to the Java applet. And then the Java applet can cause some activity. There are different types of attacks. So, for example, the denial of service attacks, the sabotage attacks. There are possible manipulating the system and spying out informations. There are risks, a type of attack by so-called inter-applet manipulation. This is possible to exploit implementation errors in the Java virtual machine or in other things. So I will go into details of these mentioned attacks in the following. Let's start with having a look to the sabotage attacks. Idea here, the goal is that the efficiency of the attacked system should be decreased or even paralyzed completely by the attack. This is to blame the provider of the service, or this is to cause some damage to prevent some activity or others. So this is a typical goal of such a denial of service attack. And what is the idea of this attack scenario? The attack scenario is that the CPU load can be raised to a maximum peak by a Java program, and they can occupy consecutive memory cells up to the moment the system is no more able to work in the correct way. By means of some Java system classes, for example, this class java.net.enet address, DNS lookups are blocked, may be blocked, which of course slows down the work of the attacked system substantially if it's no more possible to assign hardware addresses to internet address and vice versa. And attack it depends whether they can be performed or not from the used Java virtual machine GFC implementation. And since we have said Java can be run on each platform, so we have many different implementations of such Java virtual machines for any system, for any platform. And so in some platforms, there are some mistakes in the implementation that make it possible to perform such type of denial of service attack. The next attack scenario I mentioned, the attack goal was the manipulation of system and to spy out information in this way. And this can be done by Java, at least sometimes, that one can perform unintentional actions on other systems. One can cause, by means of a Java applet, that system sends emails over an SMTP port, or by means of a Java applet, sometimes it's possible to force the system to do some DNS lookups to resolve fabricated domain names. Or Java applet can force a client web browser to access fabricated to access fabricated URLs to pages with some miscellaneous content. Or by means of applets, one can force the system to read the system clock to find out some system properties or others. The goal in any case is to spy out information of the systems behind a firewall. Typically, this is a part, or this is the first step of a break-in attack. So this information that are gathered in this way, for example, that are sent by email to the attacker's system, this information helps to prepare a future attack, for example, future break-in. As another security risk in the context of using Java and Java applets in the internet are so-called inter-applet manipulation. Idea here is that with assistance of a Java applet, an other applet can be discovered and the operational parameters can be found out or even manipulated. So running one applet, one can find out the existence of other applets and one can find out details of other applets, and this is this inter-applet manipulation. So for example, it's possible to identify applets by accessing process lists in the thread group of a Java virtual machine. And then one can get the information. Then, for example, by calling a stop and set priority, the active process can be disturbed or even decelerated. The fourth attack, or say the fourth risk I mentioned, speaking about Java, was exploiting implementation errors. And here come some examples for this attack scenario. Up to now, the most serious security leaks of Java were caused by defective Java implementations. Not by Java, there was not detected a mistake in the design or in the Java. The most attacks and security leaks that were detected depend from the different Java implementations. Nevertheless, one has to state that nowadays the Java interpreters have reached a very high security standard. So when we speak about such leaks, it's not that we say all is unsecure. Even if it's very secure and if it's very correctly designed and good ideas, then there are some possibilities to misuse things. And one has to understand where are these weaknesses in order to provide means to prevent this. So main problems in the past were faulty bytecode checkers. Bytecode checkers which did not correctly check Java programs for illegal program sequences. So to give an example, the following illegal instruction sequence was not identified by a meanwhile deprecated bytecode checker and produced subclasses of privileged system classes. So this was the illegal sequence. It would be possible to find out that's illegal, but the bytecode checker was not carefully enough designed. So the result was that the own class loader or security manager could be defined afterward. victim systems could be totally controlled. So it was possible that from outside, as control is taken over the system of the client. A second example of such exploiting implementation errors is so-called package name attack. And here the idea is that if a packet name started with a character /, it was interpreted as an absolute directory path. And system tried to load specified Java code from local hard disk. And since the code came from the own system, it was executed with trusted. It was executed in the trusted mode. And this is the danger of this Java applets. It's code from an external source we cannot control, we have not insight, and it's run on our own, on our local computer. And if there are some mistake or some weaknesses, such problems can occur. So if an attacker was able to place a special applet on the target system beforehand, then he should prepare a later break-in by means of this package name attack. Let's come to another tool that makes the web so attractive, so dynamically, and provides interactivity tools and others. And this JavaScript. JavaScript is the original name, for example, was LiveScript. The JavaScript is a programming language that immediately can be integrated into HTML syntax. Also here the idea is that the instructions, the JavaScript instruction, are transferred with this HTTP communication from the server to the client, and then they are performed within the web page on the client side. Although Java and JavaScript sound very similar, they have nothing to do with each other. It was a simple marketing trick of Netscape to make, because Java was very famous, it was considered the programming language of the internet. So Netscape used this and tried to sell its LiveScript by the name JavaScript. So be careful not to mix. These are completely different things. The idea of JavaScript is that it should become easy for a web author to check in the completeness of a forms input, to control the presentation of data and the graphics within a web page so that they look like very nice. It should be easy for the author to define output screen size and the behavior of a Java applet. This is the idea of JavaScript. Also here, to make it easy for the user, to give him tools in hand that he can control the interactions with such a website. This JavaScript is a genuine interpreter language. With each execution of a JavaScript program, the JavaScript comments need to be newly interpreted. The access to the hard disk of the client system is not possible due to security reasons. Also, with JavaScript, JavaScript does not come with such a very dedicated security concept like the sandbox in the case of Java. The JavaScript programs can be easily inserted into a web page by means of the HTML tagged script. And JavaScript has some predefined objects, history, text, windows, to directly access browsers, function elements such as URL, such as history, or just a presented web page very easily. And what is important to consider is the possibility to manipulate users' web browser cause a serious number of problems. So security is if you want to say, is more dangerous than the Java. And the idea here, or the dangerous, comes from the fact that the possibilities to manipulate the user's website provides different attack possibilities. For example, the so-called JavaScript MIME attack, or the website monitoring, or the hijacking of websites, or the XSS attack. So I want to speak about these attacks in the following in more detail. There are more attacks misusing JavaScript, but these are interesting ones and paradigmatic ones. So let's start with a few words about JavaScript MIME attacks. And here the idea is that it is characterized, so it's the misuse of the JavaScript form object. Meanwhile, this is an historic attack, so it's no more possible in this way, but it's good to understand what was possible and what are the ideas to attack a system. So the attack scenario looks like following. The form object is sent to a ZGI or to a Livewire server. This is part of the Netscape Enterprise server, now typically known as Sun Java System Web Server. And the answers can be sent in MIME format and can be presented directly in the window specified by the target file. Thus also, in this way, also MIME files with undesired operations can be transferred directly to the system of the user and the JavaScript system user. So if this if there are any kind of manipulation, it's directly sent and executed, interpreted on the user side. Another attack scenario with JavaScript is a monitoring of the user behavior on websites. You know and remember the storage of user-related session data. It's forbidden in Germany. It's forbidden by data protection. It's possible by means of JavaScript functions, and particularly in the context of Ajax. Attack scenario looks like follows. The attacker modifies a victim's web page. He can do this manually, or he can do this dynamically scripted to send information about the user's activity back to the server. So the server is by means of JavaScript controls able to control, to record, to see all the activities that the user did. So interesting information for the scenario is every information that can only be collected on the client side. Only activities on the client side. In this way, it's possible over the internet from a distanced located server to see what client is doing by means of JavaScript controls. Usually, the user has no idea and does not see what's happened out, and so he cannot become aware that he or she is spied out. The implementation of this attack is done by using Ajax calls. A third idea to attack, to misuse JavaScript to attack a system by means of JavaScript tool is misusing the implementation issues in older browsers. Although this is historical. Here the idea was to misuse JavaScript and URL referrer to open a second browser window by means of this control. And this is no more possible in actual browser versions, but it was possible in many older versions. And the attack scenario was the following. After closing the second browser window, a copy of the last web page is presented instead of the previously URL. So a faked website is shown with content, with malicious content. In this copy that's shown instead of the original, the previous URL, in this copy, links were manipulated. Links were manipulated by the attacker, who herewith obtain control over future actions of the user. Because when the user follows this faked links, then he comes to website of the browser, or he gets access website with some malicious code or others. In this way, it's something possible like hijack the login forms. The login forms of the server with access restrictions, and the passwords can be discovered easily. So this is the idea of misusing JavaScript, what is subsumed under the title hijacking of websites. The last attack I want to, or attack scenario or attack idea I want to mention, speaking about JavaScript, are so-called hybrid attacks. These are modern attacks that often don't aim on the user and its browser, but are used to attack the web applications. Here, particularly, the attack scenario is based on especially JavaScript that offers some functionality that makes it possible to different attack scenarios. Cross-site scripting, I have mentioned this already, cross-site request forgery, and these two attack families we will discuss in the next lecture about weaknesses of the web. A few words about ActiveX. ActiveX offers some similar functionality like Java and like JavaScript, and it offers this for Microsoft Windows platforms. This ActiveX extends the so-called OLE controls, the object linking and embedding functions for the use within web documents. These OLE controls, these OLE functions were originally designed to connect Windows documents with certain applications. And this mechanism is extended so that also web documents can be connected to certain applications. The programming language that's used for ActiveX is an internet-capable extension of Visual Basic. And meanwhile, this ActiveX is part of the Microsoft architecture DNA, the Windows Distributed Internet Applications architecture. Over history, there are many security leaks become public and were discovered in these ActiveX applications. The major security problems with this ActiveX control is that ActiveX controls are executed with the user's rights of the currently logged in user. And if this currently logged in user is an administrator, then these ActiveX controls are performed with administrator rights. And so in this way, web pages can be created easily that are able to override important system files, to manipulate system files by means of ActiveX controls. And this can be done with a few lines of Visual Basic code. Here are some protective measures in the context of ActiveX. The most important measure is to simply deactivate ActiveX functions. If ActiveX functions are needed, then use ActiveX only temporarily, only in the context of the current task. And only install ActiveX control from reputable organizations, so-called well-known websites. Not from any other one, you know, with this phishing, the idea is to let attackers' website look very much like such reputable, well-known websites, and then if you use and ActiveX controls are available in combination with such fake websites, it causes problems. Then deploy commonly used ActiveX control, only allow what you are needed, and then use HTTPS for accessing websites. There are more such protective measures, but the most important is here this deactivate the ActiveX functionality. A few words about PDF. PDF, the portable document format. What has PDF to do when we speak about web attacks in the World Wide Web? So we see more and more attacks misusing PDF standard, misusing Flash and others. And I want to say a few words about this. So PDF is a standardized format to represent documents. This PDF format is widely used in the internet, so it's in global standard, a global format, so that in any browser, any system, you can consider a document, a PDF document, and so it's a good and it's easy to exchange documents in this way. This PDF is independent from hardware and from the platform that is used. So you can have PDF, you can see PDF on your desktop, you can use it and see it on your laptop, on the tablet, on the smartphone. So it's really globally available, and this we will see make it dangerous. PDF is also independent from the operating system that's used. You can see documents. You can use PDF format with Windows system, with Unix, Linux systems, with Mac OS X systems, with Android, whatever you like. And it's independent from the viewer application. One can use external viewers, for example, like Adobe Acrobat, XPDF, Foxit. You can use browser-integrated viewers, Safari, Chrome, Firefox. You can use browser plugins, the Adobe Reader plugin, PDF.js, whatever you like. It is independent. And this makes the large attractivity of this format that can be considered and used on every device in every system. PDF was first time released as an open standard in July 2008. And of course, it's under steady development. And the development mainly consists in adding more and more features that make it interesting to users and to make it attractive to users. The current version is 1.7. PDF has been found out over the last years that PDF has been a major source for break-ins. And it's clear, it's very attractive for attackers to think about, to find out methods to misuse such a globally distributed standard for the bad goal, for example, to break in. What are the major security risks, speaking about PDF? It's the wrong parsing by the viewer applications. And this may result in buffer overflows. Idea is to crash the browser, to enable remote exploits or others. And the reason is there are so many viewers, there are so many viewer applications, different viewer applications, and some of them are faulty. Another major security risk when one uses PDF is the dynamic content with JavaScript. This was possible from version 1.3, and this may be manipulated to execute malicious code on the host side. So in this way, the PDF, it's very comfortable in use, but in last years I had found out that here it is for security reason, it's a major source for break-ins. Let's speak about Adobe Flash. Adobe Flash is a multimedia software platform that was originally created for animations, games, and vector graphics. Meanwhile, now Flash is frequently used as a to stream videos for advertisements and interactive multimedia content over web pages. So also it's a very popular platform. There are the most used formats are one times this SVF, shocked wave flash, and the FLV, the flash video. The flash viewers are often integrated or as plugins in a browser. For example, the Adobe Flash Player plugin and others. And here, similar like with PDF, there are major security risks that the Flash cookie may compromise users' privacy. So this is here in the using this Flash cookie, one can spy out many of the users' activity. And then there are various vulnerabilities in the Flash programming language. For example, ActionScript, JavaScript, Flash language. There are some vulnerabilities that make it possible to manipulate bytecode. And manipulate bytecode. Bytecode is performed on the client side, so it's dangerous. So also this Flash, similar like PDF, these are applications that are shown or performed on the client side, provide a lot of major security risks one has to be aware of it. Let's finish this lecture with a few remarks about protective measures. Protective measures for the web browser. In the next lecture, we want to speak about the web server and attacking web servers, and then we have to speak about how to protect web servers. But now we have to say a few words about protecting measures for web browsers. Here, it's important. Regularly delete the browser cache after finishing a session. Because this provides, we have discussed this, possibilities to attack, to misuse content. Deactivate history functions. Delete history files after closing a session. Of course, security every time, convenience and security, one has to find a good trade-off. And it depends also from the system, for which purpose the system is used. It's mainly for serving in the web, or it's performed for performing some important internal function. So this depends whether you decrease or limit the space, or whether you completely delete this. Then deactivate cookie function or delete cookie.txt, and this is, I think, the most practical, because deactivating is also inconvenient for the users, but one can set it read-only. Modern browsers offer such a privacy surfing mode for usage in untrusted environments, so users. Then it's possible to anonymous web serving or mailing. And this is possible by different services, for example, here by this anonymizer provided by www.anonymizer.com. The Tor anonymizer, so-called onion router approach, makes it possible to anonymous web serving, but also misuse of these services by criminal persons are known. Then the anonymity provider offer also complete anonymity in the internet. There are different possibilities. Then a general hint is to install most current security patches. Most current security patches before Java or JavaScript programs are used. Do not be lazy, it's easy, and meanwhile it's also convenient to update systems and to install patches. Do not install plugins or add-ons that are untrusted. Neither install nor use untrusted plugins and add-ons. Then use JavaScript only in exceptional cases and only for trustworthy pages. JavaScript. In case of special security requirements, do not use JavaScript at all. You have to deactivate it because there are a lot of security problems. But this is only special if you want to run, whether you have to perform special security requirements. Then it is important not to activate Java and JavaScript at the same time. When I discussed the attack scenarios, you saw either work with Java better or with JavaScript, but never with both at the same time. Deactivate ActiveX on principle. Use proxy server and only let pass URLs, Java applets, JavaScript modules that are checked before. So these are a few hints. About protecting measures for the web browser. And here is a short view on what we have discussed in the next lecture, because the title is Weaknesses on the World Wide Web. And in this lecture, today's lecture, we have only spoken about one category of attacks, on the category of attacks against on the client side. Next lecture is about attacks on the server side. So in the next lecture we will discuss attacks that aim to break into web servers, and we will discuss how to secure web services. We speak about URL and CGI attacks. We will speak about SQL injection. We will speak about cross-site scripting, cross-site request forgery, and attacks on internet applications. And then I will finish next lecture with some overview, with some challenges of the SOA, service-oriented architecture, and the SOA security. Thank you for your attention.